Every single night you look up and see something so ordinary you've probably never even given it a second thought, just darkness, punctuated by a few stars. But what if I told you that completely unremarkable observation is actually one of the most profound clues in all of science? Welcome to this explainer. We're going to take that familiar black sky and transform it into a totally mind-bending cosmic revelation.
Okay, let's just jump right into this contradiction. For centuries, the absolute consensus among astronomers was that the universe was infinite, eternal, and completely packed with stars. But if all that were actually true, we run headfirst into a devastating logical problem. Think about it like this. If you're standing in an infinitely large forest, no matter which direction you look, your line of sight is eventually going to hit a tree trunk, right? Well, the exact same logic goes for space. If the universe just goes on forever and is filled with stars, every single line of sight from your eye should eventually land on a star, which means the night sky shouldn't be dark at all. No way! It should be a blinding, uniform wall of fire, literally blazing as bright as the surface of the sun in every single direction.
So the crazy thing here is that our familiar, peaceful dark sky completely shatters classical physics. This giant contradiction between what we literally see with our naked eyes and what early cosmology predicted, well, that's formally known as Olbers Paradox. It's a deceptively simple question. If the universe is filled with stars in every direction, why on Earth is the night sky dark? That gap between a blazing expectation and a pitch-black reality isn't just some trivia about empty space. It was a massive cosmological paradox that straight up stumped the greatest minds in history. The airtight trap these scientists found themselves in rested on four assumptions that honestly seemed perfectly reasonable at the time. First up, infinite size. There was no physical reason to assume the universe just had a brick wall or an edge. Second, eternal age. The idea of the universe having a specific birthday felt, well, a bit too theological for some, so they just assumed it had always been there. Third, that it was static. Even Albert Einstein initially assumed the universe wasn't expanding or contracting. And finally, uniform star distribution, meaning stars are just spread out evenly everywhere. Every single one of these common sense assumptions turned out to be completely flawed. But back then, together, they made the paradox mathematically impossible to escape.
Let's actually walk through the mathematical heart of this paradox, something called the shell argument. Imagine the universe is a giant onion, with Earth right smack in the middle. We're going to draw imaginary, hollow, spherical shells around us, layer by layer. As you go farther out, the surface area of each shell naturally gets bigger, specifically growing by the square of the distance. And because it's bigger, it holds way more stars. But here's the catch. Because those stars are further away, their individual brightness drops by the exact same mathematical ratio. It's called the inverse square of the distance. So the increasing number of stars perfectly cancels out their decreasing brightness. That means every single shell, no matter how ridiculously far away it is, contributes the exact same amount of total light to our sky. Add up an infinite number of shells, and boom, you get infinite brightness.
The logic was so solid that it absolutely haunted astronomers for hundreds of years. Just think about this timeline for a second. As early as 1576, Thomas Digges was already scratching his head over it. Then, in 1610, Johannes Kepler tried to use the dark sky to prove the universe just had to be finite. Skip ahead to 1720, and Edmund Halley is presenting the problem to the Royal Society, with Isaac Newton sitting right there in the room. But it wasn't until the 1820s that Heinrich Wilhelm Olbers fully formalized it, which is exactly why it bears his name today. It is wild to think that history's greatest thinkers were totally stumped by the simple fact that it gets dark at night. Now, as you can imagine, there were plenty of obvious solutions tossed around over the years. Olbers himself actually thought he had it figured out. He suggested that clouds of interstellar dust were simply absorbing the light from distant stars, kind of acting like a thick cosmic fog. And this is a brilliant example of how tricky physics can be, because the thermodynamic reality completely destroys that theory. Think about it. If dust were absorbing infinite starlight, that dust would absorb the energy, it would heat up, and eventually it would start glowing just as brightly as the stars it was trying to block. You can delay the heat, sure, but you cannot destroy the energy. So that dusty fog, it would eventually become a wall of fire itself. So who finally cracked this thing? Well, in one of the most astonishing twists in the entire history of science, it wasn't an astronomer who first intuited the right answer. It was the poet and author Edgar Allan Poe. Yeah, really. In his 1848 essay, Eureka, Poe essentially guessed the qualitative resolution decades before physicists actually worked out the math. He realized that the background of the universe is just so immense that the light from the most distant stars simply hasn't had enough time to reach us yet. He instinctively understood that light has a speed limit and the universe has a ticking clock. And that brings us to the heaviest, absolutely most profound concept here, and the primary resolution to Olbers Paradox: 13.8 billion years. See, the universe is not infinitely old. It had a definitive, undeniable beginning at the Big Bang. Because the universe has a finite age, and because light travels at a finite speed, about 300,000 kilometers per second, there's a strict, hard limit on how far out we can see. Time simply hasn't allowed the light from stars further than 13.8 billion light-years away to complete that unimaginably long journey to our eyes. This finite age totally shatters our earlier onion metaphor. We don't have an infinite number of shells to add up anymore. We are sitting inside a finite spherical bubble called the observable universe. Any stars or galaxies that might exist out beyond this cosmic horizon simply cannot contribute to the brightness of our sky because their light is literally still in transit. It's sort of like looking at a road that just started being built. No matter how clear your view is, you can't see a road that hasn't been constructed yet. But wait, there's even more to the story. While the finite age of the universe is the main reason our sky is dark, modern cosmology gives us a few other fascinating secondary factors. First off, space itself is expanding. When light from distant galaxies travels through expanding space, the very fabric of space physically stretches that light out. This stretches the wavelength toward the red end of the spectrum, a process we call redshift, and it pushes the light all the way into invisible infrared and microwave frequencies. Plus, because these galaxies are zooming away from us, the actual photons of light arrive less frequently. And on top of the whole shebang, stars don't live forever, right? Their finite lifetimes strictly limit the total amount of energy they can ever pump into the night sky. Now prepare to have your mind absolutely blown by some recent data from the Hubble Space Telescope. When we look deep into the dark, seemingly empty gaps of the night sky, we find that there are roughly 2 trillion galaxies in the observable universe. 2 trillion! This means that, technically speaking, the sky actually is completely covered by galaxies. If you hold up a needle and point it at any completely black patch of the night sky, you are pointing at a galaxy. But because of that expansion of the universe we just talked about, all of their light has been stretched, diluted, and shifted into invisible wavelengths. So the sky is entirely full, but your human eyes just can't see it. And here's a crazy thought. The universe is actually getting darker. Back in 1998, astronomers discovered that the expansion of the universe is accelerating, driven by this mysterious force we call dark energy. This acceleration means that distant galaxies are receding from us faster and faster. Eventually, they'll be pushed right beyond our cosmic event horizon, receding faster than the speed of light can ever travel back through expanding space. Those galaxies are going to be permanently swept beyond our reach forever. Dark energy essentially guarantees that as the eons pass, the night sky is only going to grow emptier and darker. But okay, here is the ultimate twist to our cosmic detective mystery. The sky isn't actually dark at all. Seriously, if you could somehow magically swap out your human eyes for ones that could see microwave radiation, the night sky would look exactly like what those classical astronomers feared. It would be a blindingly bright, perfectly uniform wall of fire in every single direction. The light is absolutely there. We are just completely blind to its glow. That invisible wall of fire is called the cosmic microwave background, or CMB. It is literally the residual afterglow of the Big Bang itself. About 380,000 years after the universe was born, the whole thing was just this hot, dense plasma. When it finally cooled down enough to become transparent, it released a massive, universe-wide burst of radiation. That ancient light has been traveling toward us ever since, stretched by the expanding universe from visible light down to a tiny whisper of microwave energy at roughly 2.7 Kelvin. So when you stare up at the dark sky, you aren't looking at nothing. You are looking directly at the birth of the universe. Which brings us to our final thought for today. Olbers Paradox takes a totally everyday observation, the dark night sky, and turns it into a massive scientific discovery. Darkness isn't just an absence of light, it is vital data. It proves that the universe had a beginning, that light has a speed limit, and that space itself is expanding. So I'll leave you with this question. If the pitch-black gaps between the stars are actually a visual record of the universe's explosive birth, what else in our everyday lives are we entirely missing, simply by taking the mundane for granted? Keep looking up and never stop questioning the obvious. Thanks so much for joining me on this explainer, and I'll catch you next time.